Okay, good afternoon, everyone. My name is Dr. Eric Toring, and I'm the Senior Vice President for the American College of Veterinary Preventive Medicine. I would like to welcome you to the webinar this afternoon. Today's webinar is sponsored by the American College of Veterinary Preventive Medicine, the American Association of Food Safety and Public Health Veterinarians, the National Association of Federal Veterinarians, the National Association of State Public Health Veterinarians, and the U.S. Animal Health Association. So it is my great pleasure today to welcome Dr. Kathleen Hartman. Dr. Hartman is currently a senior staff veterinary medical officer with USDA APHIS Veterinary Services Aquatic Livestock Health Commodity Center. Kathleen has been with the USDA APHIS Veterinary Services for over 22 years. She received a master's in fish nutrition from the University of Maryland, College Park, and both a DVM and PhD in aquatic animal pharmacokinetics from Virginia Tech. In her current position, she has traveled to both India and Indonesia in partnerships with FDA GIFSAN to provide training on shrimp health and food safety. Dr. Hartman has served on both the AVMA Aquatic Animal Medicine Committee and Food Safety Committee for multiple terms. She is a current director of the board of the World Aquaculture Society and is a past president of the U.S. Aquaculture Society. So please give a warm welcome to Dr. Kathleen Hartman.
Thank you, Eric. I appreciate that my introduction is a mouthful, but really want to thank you and Dr. Castle for the invitation and to everybody attending today for your attention and interest in aquatic livestock health management. I hate to preface any talk I give with a little caveat, but I realized as I was reviewing my slides for today that what I will be sharing with you today is uniquely from the perspective of a regulatory agency overseeing aquatic animal health. To date in the United States, aquaculture has various federal and state entities that oversee different aspects of aquaculture in the United States. And I did add several slides at the beginning of this talk to introduce all of you to what aquaculture is and share with you a little bit why I am so passionate and committed to this sector of agriculture in this country. And so again, we're not going to be taking a deep dive necessarily into the farm management practices, but rather a very high level view. I have offered, if this topic is something any of you would like to dive deeper into or hear other speakers or perspectives, I will do anything to connect you with other fantastic speakers, industry representatives, to advance our collective knowledge to support domestic aquaculture in the United States, whether it's for commercial production purposes or conservation activities. All right, you guys, here we go. So production aquaculture is a lot of really great things. It's sustainable and efficient agriculture. It provides domestic food security and independence. It can do resource protection and conservation by alleviating the collection of wild animals, whether that's ornamental species or wild-caught aquatic animals that land on our tables around the globe. Aquaculture, is one solution to avoiding overfishing and conserve many of the species that we have out in the wild. And so there's a beautiful balance here of how a commercial production side of things can also positively impact the conservation side of these activities and the species around the world. It also obviously, particularly this sector of ag, promotes rural and coastal enhancement, provides jobs and infrastructure in these areas. One of the things that I love about aquaculture is literally it can be done anywhere on almost any scale. Hopefully some of you have already experienced this, maybe with some home aquariums, that type of thing. But really, we do see with aquaponics, where we're growing vegetables and fish together, that's a great complement, can be done out the back or at the bottom of a restaurant. All these opportunities are still in front of us here in this country for production aquaculture. I do want to share with you a little bit about what the status of production aquaculture is in the United States, so you can kind of sink your teeth into what this looks like across the nation. Right now, we are sitting just under about 4,000 commercial fish farms around the United States. We did have a little bit of a decline, but we see those numbers now popping back up. And despite that incline on that line graph in orange, you can see that the contribution and economic value of aquaculture is incredibly important to the economies and the communities that have aquaculture as part of their environment. The map on the right there shows where really the density of aquaculture is in the United States. I'm sitting here in just south of Tampa, Florida, at a University of Florida's Tropical Aquaculture Laboratory. This facility provides diagnostic and extension services to the ornamental fish producers, both in Florida and around the world. And so that number down there is largely because of those farms here. As we move across the southern belt there, we see another dark blue state there. That's largely due to the catfish industry and also the farming of crawfish across Louisiana and those southern states. So there you go. That's where aquaculture is being done. You can see all but 2 states are doing aquaculture. And of course, many of our territories are also involved in aquaculture as well. Again, just showing the concentration and value of the commodities coming out of these states. These are great new graphs that we have from 2023, the aquaculture census that was just made available to us a couple of months ago. So these numbers are fairly recent. And again, if you look at the bar graph on the right, you can see food fish. So that's the catfish, the salmonids, rainbow trout, and Atlantic salmon, tilapia, redfish. We have got such a diversity of aquaculture. And that's also one of the other things that drives my passion for this sector of industry is the diversity of this sector. Not only do we have thousands of species, aquatic species in production. In fish alone, we have over 800 species and varieties being cultured in the United States. And again, that's just in fish. But globally, there are close to 6,000 to 7,000 species being cultured around the world. And that dwarfs poultry, beef cattle, dairy cattle, and pigs as well. So again, not only the species that are in production, but the extensiveness of the farming practices. We can go from completely subsistence farming, extensive farming of animals, to very highly intensive, closed, controlled environments for really intensive production on that end. And of course, we have a myriad of end uses of our animals in these systems, ranging from obviously food, ornamental, pet, public aquarium animals, research animals, animals that contribute to feed ingredients, cosmetics, other human consumed things. And of course, that's just the animal side in the United States. And of course, we lag the rest of the world. But we are also seeing a huge explosion in the production of macroalgae or sea vegetables that, of course, contribute to cosmetics, ice creams, all kinds of ingredients, as well as being sushi grade level stuff for our tables and healthy eating around the country. So really exciting and pretty current numbers here. If you do eat seafood and you're paying attention to the cool label, the country of origin labeling on the products that you eat, you will appreciate from the grocery store shelves that much of the seafood that ends up on our dining room tables are imported. In fact, that statistic is we sit at about 85% imported seafood in this country. Now that's for a couple of different reasons, and we can't think that just by cutting off the imports or solving the deficit there that we will impact, because some of our commodities really rely. Here in Florida, we have 90% of the world's Vaname broodstock. Those are the white-legged shrimp that typically end up on our dining room tables. We have the broodstock here in Florida because we're pretty stable um, environment for these cultures to be grown. We don't necessarily have the footprint or labor capabilities in this country to grow those shrimp to the table size animals. So our industry for the shrimp sector largely is the broodstock and the young life stages, the post larvae that get exported from the United States and then of course come back as an imported seafood product. However, I think it is important as we begin to focus and pay attention about the trade deficit and human health and wholesome food available to American citizens, that we pay attention. How can we better support aquaculture in this country and begin to address this trade deficit? What opportunities are there for us to expand, support aquaculture? In that vein, again, aquaculture can be done in many different capacities. We've got in these couple of images here, pond aquaculture. That's a picture from the Mississippi Delta, likely a catfish farm. Many of those ponds contain the animals, but a lot of that water there is the recirculation and reuse of some of that pond water to the culturing ponds that have animals in them. We also, in that upper right-hand picture, that's a coastal picture of a clam farm up in Maine, and you can see again they're utilizing that coastal state water space to grow oysters, clams, gooey ducks, um, uh, mussels, all kinds of things there, again, in those coastal environments. In the bottom picture on the right-hand side, that's an image of one of these large recirculating aquaculture facilities, all indoor. Water is nearly 100% reused. New water is added to address for loss to evaporation and other reasons. This land-based type of culture, this recirculating or RAS systems, are really where we see the future of aquaculture going. And the size of these facilities can really be varied from one room to multiple rooms to a huge warehouse type situation. And of course, then we have the net pen culture there on the bottom left-hand side, where we've got net pens that sit on the surface of the water, and the net infrastructure, of course, goes down into the water, and the animals are produced in those cages. These are the primary means of aquaculture production in the United States currently, but really where we are going in the future of aquaculture, it's beginning to look really interesting out there. These are ocean vessels. China already has a fleet of almost 10 of these, and we see the same type of systems being developed in Norway, Chile, and many of these will be in international waters. And so we can expect that these vessels will be bringing fish, either U.S. origin, aquatic livestock, or livestock from other parts of the world to our shores for the freshest seafood that we can possibly imagine here. But again, these are ocean vessels that'll have tanks and tanks of different life stages of animals. We already know we have in the process of the regulatory environment, one company that is taking this to be off the coast of Washington State. So this is a lot closer than we could probably likely imagine, but really cool processes there. Again, this is farmed. The fingerlings would be sourced from a land-based recirculating aquaculture facility. The fingerlings would be taken out to these vessels, stocked, and then periodically come into state or federal waters to restock feed, change out labor if that's necessary, and other logistics and supplies that are needed on board. So this is really kind of what the future looks like. I used to think that it was all the net pen culture and the submerged cages underwater, but the more I see and read about this, this does seem like where the future is going. What's also really cool to appreciate about these vessels is that they will be taking on water from the ocean that is highly double filtered going in, so that they're removing all risk of pathogen or contaminant entry into the containment areas where the animals are being held. And then the same treatment is done to release the effluent leaving the vessel at the times that they need to discharge any effluent from these vessels. So they will be releasing water that is super clean back out into the environment. So pretty cool operation there. When we talk about the sustainability of aquaculture in comparison to other livestock commodities, and this is not a competition or anything like that, as many of our aquaculture producers in this country say they still love to eat steak and all the other protein choices that we have. But really, what I want to make absolutely just one of the things you remember about today is how resource efficient growing some of our aquatic animals really can be. And you can see here really competitive feed conversion ratios. The freshwater consumption there is pretty incredible. The carbon footprint, protein retention in the edible fillet parts, and just really how efficiently these animals are able to utilize the nutrients that are putting into their systems and into their bodies. You'll notice, of course, that clams or mollusks are not present on this slide. One, because those animals are absolutely all the time cleaning the water as they take nutrients in from their natural environment, and then outputting some of that really filtered, animal filtered water that looks great. So highly efficient animals there. But again, just to give you a feel, by comparison to the other livestock, aquaculture does seem to be one of the most resource efficient ag sectors that we've got going, which is so exciting. All right, and I'm sure you guys are now like, okay, this is about preventative veterinary medicine. Let's go. So let's go. So why is disease, in particularly infectious disease prevention, so important in U.S. aquaculture? And I've listed just a couple of facts here. One is that currently, and it has been this way since I started my career in aquaculture, our farmers have a very limited toolbox to address animal health needs, not only in the regulatory capacity, but the social capacity as well. They are getting immense pressure from their clients and, of course, society in general to have animals landing on our plates that are antibiotic free, GMO free, all that kind of stuff that all the other sectors are battling with as well. But our guys, they only have less than 5 available antibiotics. There are a little more that are approved, but even if you got a script for them, you can't find a company that'll make the medicated feeds for it. So really, they are limited to 5 antibiotics. And I'm sure you all understand, in comparison to the other commodities, this is a very small arsenal of being able to target many of the bacterial infections that these animals are up against. And of course, if you're a shrimp farmer in this country, you have no antibiotics available to you to use to combat some of the more serious bacterial infections that those animals get. So our guys in this country are 100% dedicated to disease prevention because they don't have a lot of treatment options on the back end. Also, right now, there are only a handful of vaccines that are available for fish species. I've provided the QR codes to both of those documents on this slide. Many of those vaccines as well have been around for a really long time. And there's some debate about their efficacy at this point. And of course, getting companies, pharmaceutical companies, to invest in getting new drugs and new vaccines, that's a really tall and expensive order to ask for an industry that really is, in this country, at least still very small. Also, we have many pathogens in the aquaculture space that have very broad host ranges and also a wide environmental range as well. Viral hemorrhagic septicemia, of course, can affect over 28 species of fish in both fresh and marine environments. And this infectious spleen and kidney necrosis virus, ISKNV, affects literally a list of species that is longer than I am tall. And so, again, being able to approve drugs for these huge list of pathogens or species that are susceptible to these pathogens is a super tall order. Once these, if a pathogen, viral, fungal, parasitic, and bacterial are introduced in any of the environments I've talked about, whether it's the pond environment, tank, or recirculating aquaculture system, because of all the infrastructure, the plumbing, the biofilms that can protect some of those organisms, it is really hard to eradicate these pathogens in most environments once they're introduced. And of course, now many of our trading partners, as well as state agencies across this country, for whatever reason, whether it's an invasive species issue, a pathogen issue, they are now asking our aquaculture producers for their written biosecurity plans. And so I don't know what happens in the other sectors. I imagine with high path and African swine fever that trend is also there as well. But it's been a big learning curve in aquaculture to have a written biosecurity plan that really documents the justification and the mitigations that are being done on these farms and what those processes are doing. All right. So when we talk about risk management to our farmers and to other federal agencies, we want to make sure everybody understands their role in this very big picture, right? That it can't just fall to the level of our farmers to bear this burden to demonstrate risk mitigation practices. And so this slide just, again, is to remind all of us that biosecurity is a shared responsibility, whether at the national and international level through the WOA standards. If you're not familiar, in addition to the terrestrial code and manual, WOA has the aquatic code and aquatic manual. Most competent authorities around the world default to the aquatic code to provide what species are susceptible to different pathogens, what products and how products need to be treated to ensure that those products are safe, either for as a feed ingredient, so that we're not introducing pathogens through that pathway on our farms. Then, of course, we come down a little bit smaller to the region. How do state governments, tribal entities, and everybody else kind of work together to ensure that the areas that are around our farms are secure and safe from the introduction of pathogens? And then, of course, the farm itself has to bear also some responsibility in that, and understand what the region around them looks like so that they can develop appropriate mitigation strategies and, of course, develop a meaningful biosecurity plan. Many years ago, you'll find talks from me talking about hand washing and how important foot baths are. I think we've evolved a lot since then, that in certain places, foot baths make a whole lot of sense. But out here, for example, in the Florida sunshine, having a foot bath outside a greenhouse doesn't really make much sense unless it's a contaminated space. So again, working with our industry, finding those economical sweet spots where biosecurity can be meaningful and also make a difference on the farm. As a colleague from USDA, Dr. Lori Gustafson, and I have been working with international partners and the FDA to communicate, how we manage the health of our aquatic populations really translates into healthy livestock. And of course, that translates into healthy, wholesome products landing on our tables. It's literally the concept of One Health, right? The environment, the animal, and the humans all coming together. So we were locked into this pyramid type approach to how to communicate this. I think this works. This is currently where my thinking is in communicating how this all fits together. If we look at the bottom piece there, we've got, again, identifying the pathogens of concern, the introduction risk pathways, which we're going to talk about in a second, what the mitigation and biosecurity practices are to protect our farms and livestock from pathogen introduction, and of course, communication or reporting of those pathogens, not only to that local area, but also the international community, so that we are all transparent and are well aware of the risks, and we can develop strategies to prevent the introduction of those pathogens. So really, when we're talking to farmers, that bottom tier is really the external factors that drive how the farm is managing and how they need to manage the biological risks of threats coming or exposing their livestock. That middle part of the triangle there is about the on-farm strategies or tactics to mitigate and make sure that our animals and our biosecurity practices are working, right? I always try and reinforce to the farmers who are grousing about the amount of testing and the cost of testing. But when you start to think of it as a holistic type picture, hey, remember, not only are you testing in order to be able to move your animals safely, but also that test, if your biosecurity plan and surveillance plan are jiving together, that animal health testing practice and investment do translate to tell you that your biosecurity practices are working, your on-farm management are working. And so that makes that feel a little bit good. A little bit of a spoonful of sugar makes that cost of testing go down a little bit easier. All right, so let's see. So again, looking at that bottom rung, we look at these external factors about the risks to our aquaculture farms. Obviously, location. Where should a farm be located? What considerations are there regarding that environment? Is suitable water available for the species being cultured? Are there other farms in that area? How do they manage effluent coming off of their farm? All that comes into, again, influence what practices need to be done on the farm. Understanding the end use of the livestock. Are these aquarium animals that are going to be moved live? Are these animals that are going to be ending up in the human consumption arena and are just going to a local processing plant? All those things, again, influence the requirements of animal health, depending on what that end use is. And of course, the species being cultured will dictate what pathogens we need to be concerned about remembering that not all pathogens are created equally. We've got our internationally regulated pathogens. We've got the pathogens that actually cause high morbidity, high mortality. We've got the socio political pathogens that everybody's worried about, but actually cause no disease in our animal populations. Infectious salmon anemia, HPR0 is an example of that. Also, currently, Piscine Rio virus out that has made the headlines in Washington for several years now. Again, we found that pathogen, but none of our animals have ever been clinical for an infection. So, is this a pathogen we're regulating for no reason? What is that? And figuring that out is challenging. But again, there are different buckets of these pathogens, and helping our producers understand what that looks like is important. So I've had a couple of opportunities to go to India. You'll see this area of India was taken in 2009. You can see right where it's got the Nanahira Street location. That's a series of shrimp farms, Vaname shrimp farms in that area. And not owned all by one person, but the majority of those are. And so it was easy, perhaps, to manage animal health issues in comparison to Google Earth image now of the same region. And now you can see the explosion and growth of shrimp farms in this area. All these farms are obviously interdependent on each other for pathogen and health management and control. Pretty incredible growth in less than 20 years there. I mean, really incredible. And I suspect that we're going to start to see the same type of stuff here. All right, so for aquaculture, how can we easily frame this in our minds? And we've talked a little bit already about the identification of the biorisk. What pathogens are our species susceptible to? What is our farm location vulnerable to? And then what do we need to keep in the back of our mind? Can we use antibiotics? Is that even an option? Can we vaccinate? Some countries have in their export health certificates that the animals cannot be vaccinated for some of these pathogens. And so that all those little pieces of information go to inform how we will manage the health of these populations. On most aquaculture farms, the 5 pathways of pathogen introduction are animals, water, feed, vectors, and fomites in humans coming on. And so looking at each one of those pathways for each pathogen that our farms are concerned about is very important. And then identifying not only in that animal pathway, where exactly is the control point for where we might implement a strategy or a tactic to prevent the introduction of a pathogen at that point in that pathway. There are several opportunities along the line in each one of these pathways to prevent or control pathogen introduction or spread. And I'm going to go through 1 or 2 of these examples as we move along here. All right, so an important component of this too, particularly for our veterinary profession, and I think I appreciate this is happening both in poultry and other sectors as well, is how does our profession evaluate the mitigation or biosecurity practices that are being done on our farm? In aquaculture, in our program, we have created 3 buckets: secure, or you're mitigated, meaning that a human intervention was required to mitigate that risk, or simply that pathway is not being mitigated. And in some cases, that might be fine, but in some cases, we need to stop and address that insufficiency at that point in that pathway to ensure that our animals are being secure. So again, secure pathway, managed, or at risk. And again, those 5 pathways: animals, water, feed, vectors, fomites, and humans. All right, and I just have a couple of examples there. Virkon is a common, well, you guys probably all know Virkon too, but Virkon also makes a Virkon aquatic that has a little bit of an ingredient difference, so it doesn't have all the soap or I forget the word. Anyway, it's less sudsy than the regular Virkon. And of course, then if you're using surface water to come onto your farm, and it's not, you're at risk for some pathogens coming in using that surface water. What is your UV sterilization? What is your filtration method? Is that all appropriate for the pathogens of concern? All right, so let's look at a couple of examples here. Water sources. The picture on the left there, obviously we're in an open environment and we're not going to be able to control the wild fish, whatever is coming or in that waterway. Our animals and livestock out there are going to be exposed to that. So how do we begin to address those risks? The picture on the right there, and I doubled up here, but that's a picture of mine from Idaho, where many of the farms out there are able to utilize this beautiful freshwater source that's coming literally out of the earth, comes down, runs through the farm, and then is discharged on the backside. That water doesn't need any treatment coming in. It might, in some cases, not here, obviously, because there's been lots of oxygen introduced here. Water out of the ground may be a secure source in terms of pathogen, but we always have to make sure it's also of the appropriate quality before it goes. Sometimes here in Florida, if we're taking deep well water, it needs to be degassed for hydrogen sulfide and other gases that would kill our aquatic animals, and then have oxygen introduced before it hits those containment areas. So again, just a comparison there. Of course, water sources can be quite numerous. These are some of the spreadsheets that we work with our producers, and you can see the secure, managed, or insufficient columns there, where we've identified, okay, if you're in a region that has no susceptible species, history of absence of these pathogens, you are a secure water source. Or maybe you're in an area that APHIS has worked with the regional competent authority to declare that region free of certain pathogens. And we are making tremendous roads on that, particularly out west at the moment for some of our mollusk pathogens. And so that's an incredible opportunity there. So again, just to show you what this looks like and how we are working with our farms to do this. This is the animal pathway, for example. In the secured column, are animals internally sourced from an higher or equal health status to the animals on the farm? Do they participate in a verification program for animal health? If not, what are we doing in that mitigation column? We're requiring health certificates, testing, quarantine practices, all those practices that, again, would mitigate and address, minimize, reduce, eliminate those risks of pathogens coming in. All right, so that first section, aquaculture, what it looks like, managing risks on our farms, and then finally just a little piece here on aquaculture health management. We are really encouraging our producers to deploy early detection systems on their farm. This is a producer-led surveillance tactic to detect changes in the population. And this would be behavior, feeding behavior, swimming behavior. Our farmers have that gut sense, right? ADR, ain't doing right, or, fish are feeding well today. Love that. They know these very subtle, nuanced changes in animal behavior, and we want them to know, okay, these are the early things that you might recognize. If you see these things start to happen, fish go off feed, increasing morbidity, mortality over several days, these are the cues that, hey, we need to launch a disease investigation. Going back to early detection, deploying all the strategies, all the broad-based strategies, routine health screening using histo, bacteriology, virology, culture methods, so that we're not always doing specific pathogen surveillance, that we are doing broad health screening, so that we wouldn't miss any emerging pathogens that we might not detect with more molecular or targeted type surveillance practices. Of course, observational. Nobody knows their animals better than the farms or the guys or gals working with these animals on a daily basis. What do they see? And again, aquaculture lends itself beautifully to these alternative methods, in my opinion, for televeterinary medicine. Very few veterinarians are going to be diving any of these marine net pens, but how can we use remote surveillance to give an indication of animal health? What are the cues there? Can we do remote assessment of biosecurity practices in some of our hatcheries? I would say yes, because for a number of reasons it works, but the generation of practitioners behind us are way more comfortable using these remote sensing techniques than perhaps some of us older gray hair folks are. So I think now is the time to begin embracing those strategies and tactics. And of course, environmental sampling. I'm not sure we're ready yet to regulate based on environmental sampling, but can that be an arsenal in the toolbox to say, hey, we've got either a change in the biome, we've got eDNA detections of this in the environment. What are we detecting in the livestock themselves? So again, it can be an early cue to what is happening in these environments that might impact or compromise animal health. Then, of course, we do need targeted and active surveillance on our farms for trade purposes, for animal health verification purposes. One of the challenges in domestic aquaculture is that the list of pathogens that our guys in many sectors are being asked to test for are long. Over 25% of the whole WOA listed reportable pathogens are aquatic animal pathogens. It is breaking the bank, quite frankly, for many of our exporters, but it is not possible to get away from. So again, identifying the boundaries. Are we making the farm perimeter the boundary, or do we have different populations around the farm? Broodstock, fingerlings, grow out production. We can, again, do a little bit of a plug and play on what level of health certification or different pathogens as those animals move through the production cycle. And of course, again, blend observational surveillance with targeted risk-based surveillance testing, and of course, those necessary surveys or testing that is needed to move the animals. Just some quick snapshots of what this might look like in the field. Some veterinarians there taking animals, collecting the tissues. Those then get sent off to a laboratory for the diagnostics components of that. And if anybody is interested in learning more about that, happy to pull together a talk on sampling, identifying pathogens, what pathogens need to be tested for, and what those resources are. And then, of course, we've got the myriad of preventative medicine strategies and tactics. Husbandry. I'm not going to dive into any of that here. That's really probably you to hear that, you need to go to the farming community and find out, what are they doing for genetics? These guys have done such cool work in identifying the QTLs for pathogen resistance. We've identified pathogen resistance capabilities for tilapia lake virus. It's really exciting now, the breeding and the genetic advancements that our farmers are being able to make to produce and grow animals that are inherently resistant to some of these infections that would prevent trade and decimate animal health and populations that way. All right, so in my last few minutes, I just wanted to share with you some of the really cool initiatives that APHIS VS is working on. This work on declaring pathogen freedom in the United States is, I think, the key contribution that USDA has given to domestic aquaculture over my 22 years sitting here in this seat, and it is making a big difference. As I mentioned, this scenario here that is in front of you is for salmonids being moved. If they were being exported to a European Union country, there are 7 pathogens that they would need to be test free from. And again, you can see the cost of that per collection going upwards of $12,000 to $13,000 every time they want to export. That is not sustainable. Also, aquaculture in this country is still the only livestock that is demanded to test healthy animals prior to movement. I would argue that in no other commodity does that really happen to the extent that it still happens in aquaculture. And getting production aquaculture recognized as agriculture, I think would go a long way to advancing the strategies we can deploy to, again, manage that a little bit and also promote our farms. With freedom claims at the country level or the regional level, we are able to do an over 50% reduction in the cost of this by declaring that the country is free of these pathogens. Our farmers don't have to make that investment in pre-movement or pre-export testing. It's really cool. I'm so proud of this work. And again, the breaking points here, already kind of discussed these. But currently to date, we don't have a regionalization system for like-to-like movement in aquaculture, which is where we'd really like to end up and go. Of course, in order for us to implement import controls for the United States, we need to demonstrate that we are free of some of these pathogens, which this work obviously supports the implementation of import controls. Currently in the United States, we only have, well, it's a handful, right? So for ornamentals, we've got spring viremia of carp. For tilapia, we have import controls for tilapia lake virus. And then U.S. Fish and Wildlife has 4 or 5 pathogens. 3 or 4 of those are already present here in the United States for the salmonids entering the United States. So pretty limited. So again, when we think about the responsibility of biosecurity right now, we're not protecting at the country level. That falls to the region or on the shoulders of our farmers themselves. And so that can be a pretty heavy lift. Because I'm running out of time, I am going to just keep going through these slides pretty quickly. But if anybody would like a copy of my slides or anything else, please let me know. I'm happy to share. To make these country and regional claims, we are following the Aquatic Code, Chapter 1.4, and the criteria that is listed there. Components of being able to do that. Look there, early detection systems, biosecurity, and surveillance. And the things that fall under that right now are having a competent aquatic animal health services in the country. We have several laboratories that participate in the NALM, which hopefully you guys are familiar with. We also have a number of labs that are approved for export health testing. We've got a vast profession and community of veterinary and non-veterinary professionals that are engaging with our commercial aquaculture producers. And we also encourage reporting of all the pathogens that are listed by WOA. Also with under the NLRAD, the National List of Reportable Animal Diseases, we've also included additional pathogens, not on the WOA list, but pathogens that are key and critical to the trade or movement of some of the animals that our producers are growing. And of course, having an emergency response plan for when things go wrong, usually on a Friday at 5. And so we review all these different components to make these claims. Last year was the first year that we were able to claim and declare the United States free of these pathogens. We've got 3 salmonid pathogens and 3 molluscan pathogens that we've been successful. We just last week submitted these reports to WOA for recognition by them. And so we think we will be successful not only in having the USDA declare freedom, but having the international community recognize that work as well. The important component of these claims is at the country level. That includes not only our cultured or farm species, but also our wild susceptible species as well. This helps our colleagues and sister agency of NOAA. NOAA is the federal agency that oversees the export of seafood from the United States, whether that's wild caught or farm raised. And so the trend that they began to notice was that trading partners wanted assurance that wild caught seafood was free of not human pathogens, but also these animal pathogens. And I'm sure you all can appreciate that when these fishing vessels arrive into port, there is not the logistical footprint to collect samples, hold all those animals until we get test results done. And so by declaring U.S. waters free of some of these pathogens, that alleviates that burden of having to hold tissue or fillet. And really, none of these pathogens are going to be found in the muscle tissue of our animals. And so it's a disconnect. And so again, this was a strategy to alleviate that burden as well. All right. So if you're interested, again, this QR code will take you to those claims if you're looking for some light reading before bed, perhaps. But again, we're really proud of this work and are working with our regional entities, competent authorities, to make regional claims. To support this work, the resources that are available, I'm a visual person. I like to see it in a map. So we're working on a freedom map. Identifying, either at the country level or regional level where these pathogens are known not to occur. And of course, then the National List of Reportable Animal Diseases. We do have an aquaculture state resources map. On that map, it identifies who the competent authority is at each state level, what their reportable pathogens are, who the state veterinarian is. So again, our farming community and veterinarians have instant access to that information should they need to report or get help at how do I move my fish from Florida to California or Washington State. And of course, there's our general email box if you're interested. All right, so again, the impact of this freedom work, reduce the burden on our growers. Already, our trade staff has let us know that 20 trading partners are recognizing these country level claims. Super exciting. So we already see the reward in this work. And we also are seeing some success at harmonizing domestic movement of these animals. We are, again, working with our regional partners to get regionalization done in this country and support our sister agencies at addressing some of the trends that they see and they're trying to meet for many of our wild and farm-raised products. And of course, I'm a big fan of transparency. Let's not be afraid of what we've got here. Our farmers are doing an incredible job. I'm super proud of them. And this is the newest sector of agriculture in the United States. Despite fish farming being, hundreds of years old, it is the new kid on the scene. Very few import controls for animal health and few supporting programs. However, I say this, aquaculture in the United States is really heavily regulated because of water by the EPA and other situations there. I think the United States ranks 17th in the world as having the most regulated aquaculture industry. And so again, being able to be transparent about at least some of this health stuff goes a long way. And again, I presented this to some of our farmers last week at a trout farmers meeting. Wouldn't it be great? We've never had a detection of viral hemorrhagic septicemia 4B in any of our animals. We have had a handful or less of VHS 4A, but our salmonid farms pretty much can make this claim that they are free. And then examples of what some of these regional claims might look like as well. if you're interested in learning about how we are approaching these open water environments where everybody's probably like, how do you do health claims in open water environments where, again, our animals are vulnerable to whatever's out there? Again, my colleague, Dr. Lori Gustafson, and this fabulous team of collaborators last year came out with this paper on a strategy on how we're doing that in different regions around the country. And again, you guys all know this. If you can't afford prevention, affording disease is sometimes the nail in the coffin for many of our farms. We are anticipating the release of a manuscript describing the impact of disease on our domestic salmonid industry, both trout and salmon. And that will show how really devastating, particularly on our small farms, the impact of disease can be. In fact, sometimes these disease outbreaks, either the outbreak themselves or the regulatory response to these outbreaks, shuts the doors on these businesses, and we just cannot let that happen. All right, here's the final slide. Has my email and my cell phone number. Please reach out anytime. I love talking about aquaculture and our fish and aquaculture producers. All right, I'm going to pause, Dr. Toring, for any questions.
Want to go ahead and pose some questions. First of all, we've got one. Do you or the APHIS, I said APHIS, do you or the APHIS staff travel to other countries to review their biosecurity and diagnostic testing for some important live aquaculture species imported into the U.S.?
So that's a great question. And Stephen, if you also from the trade side, Dr. Castle is also on the VS aquaculture team. And I know that the trade team does have exposure to international countries, obviously. My experience going overseas has been in two capacities. One, that partnership with FDA and GIFSAN, which is out of the University of Maryland. We have gone to other countries to, one, address food safety concerns of imported shrimp coming into this country. If you follow or you can Google those headlines, it's pretty clear the challenges there. So Dr. Lori Gustafson and I have been around the world with those guys to talk to shrimp farmers in other countries and their regulatory and seafood processing folks to encourage, again, healthy seafood begins at the farm. And so talking, about how to do risk management, avoid infections when we can, but if they do happen, the judicious use of antibiotics, that type of thing as well. Then also I'm part of the World Aquaculture Society. Recently had an opportunity to go to Africa, Uganda, to see what aquaculture looks like there. Obviously not in an official capacity in any way, but it does provide a depth of what I know and see around the world. I will say that the United States and our farmers are some of the best in the world and really experienced with aquaculture and biosecurity. I meant biosecurity, really, really attuned to biosecurity, which is great.
All right. Next question is about sustainability. The individual submitting the question says, we often look at this in terms of feed conversion ratio, but often seem to overlook the value and impact of the feed stuff that these animals eat. In my understanding, much of the feed for aquaculture is derived from other aquatic animals, example, lower value, smaller fish, etc., harvested from the ocean, and thus the environmental impact can be very large relative to the volume of feed required. Could you please comment on whether this is an accurate understanding and provide some additional context from your perspective?
That is an accurate understanding. But the trend has been to move away largely from the incorporation of fish and fish meal and fish oil that are sourced from those wild populations and reduce that in our fish feeds. Our feed companies, our farms, our researchers, ARS, USDA, ARS has a great nutritional capacity or nutrition component that way as well. How do we begin to minimize, if we can, eliminate those sources of fish meal? We're looking at insects. Uh, uh, I'm sorry, I'm drawing a blank on the type of insects, but insect meal is becoming very popular in aquaculture. All these alternative feeds, moving to more plant-based diets as appropriate for the species being cultured, is a huge force within the industry. And again, our collective aquaculture community understands that in order for aquaculture to grow and expand, we cannot be continually a partner in the taking of these wild animals to make feed for our farmed animals. And so there is a huge movement that is now decades old even to begin to address that concern by identifying alternative feed ingredients, but yet maintain that high protein, high fatty acid profile there as well.
Right. A couple questions about PCR testing.
Uh-huh.
Uh, is are PCR panels available for testing? And also, is that testing similar to human wastewater testing for pathogens like COVID and influenza to test that water from aquaculture farms for disease surveillance?
So that's a great question. Right now, we do not have any approved, USDA approved methods for a multi-path platform. There is a company in Australia, Genix, maybe you guys have heard about. They do pigs and other stuff as well, but they and other companies have multi-path platforms where they can simultaneously test for Genix can simultaneously test for all 18 shrimp pathogens in one sample. That is huge. We've got many researchers and companies in the United States that are also deploying these methods. Can't be used for official health testing purposes yet, but that is definitely the goal. So that one, we reduce the number of animals that have to be collected. We begin to minimize the cost and the burden of those testing. But yes, so in the fish space, we've got regular, viral culture, bacterial culture, molecular based testing methods. In shrimp, we do not have a cell line, an immortal cell line in the shrimp. If anybody is interested in investigating that further, and if you've read the immortal life of Henrietta Lacks, that opened my brain, and I was like, maybe we could find a shrimp neoplasia that would do an immortal cell line. So right now, unfortunately, our shrimp industry is really locked into bacterial culture, but more times than not, it's all single pathogen PCR based, and it is way too expensive in that manner. Now, if we're talking about eDNA and water sample analysis, so in this country, EPA, the Environmental Protection Agency, is the lead agency that requires that effluent leaving the fish farms meet a certain standard, and they include pathogens in those requirements as well. I am not exactly 100% sure how they do that. My approach and interactions with them have been, hey, if we can demonstrate that the livestock on the farm are free of those pathogens, the natural inclination would be that any effluent leaving that farm is also not going to have those types of contaminants in them as well. Also, if you're interested, USDA under the Food Safety Inspection Service, FSIS, we do have the catfish inspection program. It is a flagship USDA program because it is the one that goes to the farm. Everything else starts at the slaughterhouse door, right? But the CIP catfish inspection program under FSIS goes right to the farm to identify, are there any things on the farm in the soil that might impact the quality or wholesomeness of our catfish coming off of our domestic farms? Great question. And please, you guys, if you have any questions, I know it's getting a little long in the tooth, 5 o'clock on the East Coast, but please email me again. I love this stuff. Your questions are awesome.
Question about Washington State. They said that the Department of Ecology has shut down all farmed fish facilities. So is there no farmed Atlantic salmon
So,
production in the state?
sure. Yep, understood. Thanks, Eric. So a couple of clarifications. I don't think it's the Department of um, Ecology, and again, aquaculture in the United States, and we didn't touch on this, but at the state level, about 35 states have aquaculture and aquatic animal health under the Natural Resource Agency. In the others, it's either the state ag or some other entity. In Washington, DFW, the Department of Wildlife and Fish, oh no, sorry, Department of Fish and Wildlife. Sorry, you guys. They are the entity. So, based on a risk assessment that was conducted by them several years ago, one of our private commercial fish farms did have an unfortunate release of some Atlantic salmon. Atlantic salmon are obviously not native to that side of the country. There perhaps were some compliance issues with the amount of algae that caused the net to fail, those types of things. So also the concern over Piscine reovirus. So all that's been swirling around. So yes, DFW in Washington has banned the commercial production of Atlantic salmon in their state waters. However, that does not apply to the tribal entities that are growing Atlantic salmon out there, and perhaps some other ventures there as well. So that is correct if I've been able to correctly adjust some of that information, but that is correct. It's very unfortunate, obviously. That really hurt some of our companies that were growing Atlantic salmon out there. And they are fighting that ban daily.
And we'll do a couple more questions because I tell you, this is an interesting topic. Um, we've seen the introduction of multiple invasive species and pathogens through international shipping. For example, zebra mussels into the Great Lakes as a result of ship ballast water discharge. Is this a threat to the U.S. aquaculture industry, especially in the farms along rivers and shorelines? And if yes, what is the USDA doing to protect the industry?
Yeah, that's a great question. So yes, that is a risk. And certainly is a pathway of the introduction of not only pathogens and invasive species. So that is a critical area. We do know, and honestly, like that type of thing doesn't necessarily fall under USDA's sole authority there, but we are working with many partners internationally on understanding, again, not regulating, but at least gaining an understanding what how is ballast water being treated? How are the hulls of these vessels being deconned as they enter U.S. waters? That is very interesting. And I failed to mention that, in the United States, we have one or two states that allow offshore aquaculture. I guess that's called nearshore aquaculture in state waters, despite the United States having, I think, the fourth largest exclusive economic zone of the world. We have no aquaculture occurring in federal waters to date. That is coming, I think, for the United States. And then, of course, on the other side of the EEZ is international waters. And what we are witnessing, and I'm sorry if I'm not answering your question, it's honestly because I'm not really sure of the answer. What we see around the world right now, too, especially with those new vessels that I showed you earlier in the presentation, those shipping vessels at times are also processing and discharging the offal and agricultural waste into our oceans and waters. And certainly, I can see, and we see this already in Mexico happening, because Mexico does allow fish production in their state waters. I think it's patriarchal waters, where that activity occurring in international waters is impacting livestock being grown. And so I think this is something that the United States, and it's going to take a multi-agency approach, right? NOAA, EPA, and USDA to figure out how we are going to protect our farms, both at the federal level and also further protect our natural resources in all those different spaces, globally and nationally. It's been a long-term problem, not one that we've been able to satisfactorily address, in my opinion, yet. But I think that we are, as aquaculture expands into these different areas, the attention to that risk is going to be greater. And again, understanding how ballast water is treated, we've been working with a number of different partners in different states that are wrestling with this issue as well. How are we going to be better at mitigating those risks?
Okay, we'll do one more. In the chat, someone says, I've read a lot about farm shrimp not being very sustainable due to habitat destruction, pollution, impact of wild shrimp species, and overall higher carbon footprint than other aquaculture. Can you comment on practices that can make shrimp farming more sustainable, or how to help encourage more sustainable practices, especially since most shrimp are imported?
So I'm not sure, obviously, the source of your articles. What I can say, and I don't want to sound like, I don't know, that I don't know. What am I trying to say? If you're ever in Florida, please come with me to a domestic shrimp farm, and you will see that those things that you've mentioned there in that chat really don't apply to our domestic industry. The way we are culturing shrimp in this country is not like that and does not have that impact. So I suspect that the literature that you're seeing is not focused specifically on the United States. um, Shrimp are a very resource efficient animal, that we've got homegrown shrimp. You can look them up, and actually in YouTube, there was a gentleman that visited homegrown shrimp here in uh, Indian River, I think, Florida. It's on YouTube, and I'm happy if Eric or Steven can get that link. I'll send it to them after. It's a guy who shows up at the farm and is like, "Show me what shrimp farming is all about," and he goes through this farm, and you can really get an appreciation of, one, the level of biosecurity that these farms are under, and the resource efficiency. Like these farms in the United States are not discharging a lot of water from these shrimp farms at all. It's very resource efficient. So again, anybody, I throw that invitation out there. Anytime you are in Florida, please look me up. I'll take you to an ornamental farm, shrimp farm, sturgeon farm, wherever, so that you guys can learn and appreciate how well we're doing this in the United States. We just got to do it more.
Okay, I think we're going to close today. I tell you, aquaculture is something that is growing. My little personal story, my aunt has a friend whose grandson was a business major at the University of Nebraska. And he came home one summer and says, going to start fish farm or shrimp farming on our
Nice.
family farm. And they thought he was crazy, and sure enough, the Nebraska Shrimp Company took off, and there are numerous farmers in southeast Nebraska who are starting to take their swine barns and convert them into shrimp farms. So it's a growing business, and obviously a timely topic, and definitely we want to thank you, Dr. Hardman, for bringing it more to light to our group here. So
Oh,
thank you for the topic and for a great presentation. One of the comments in the chat is they want more um,
great.
about aquaculture. So I'm going to look back in the chat and get that to our CE committee, and we may be back in touch.
Awesome. Well, please. I mean, I am just one of one of many, but I am happy to connect you guys wherever you are in this country. There is a aquaculture farm. If you want me to connect you to them so you can go see, take your family on a Saturday, our farmers love that. And Maine has the shellfish tours. Get a glass of wine and go out on these boats and tour the shellfish farms. I mean, ecotourism for aquaculture is taking off. So please let me know how I can support any of you in finding additional speakers or igniting a passion and interest for this sector. Awesome. And thanks again, you guys.
Well, again, thank you, and to those that are still online, thanks for hanging out. As always, we're always looking for volunteers like Dr. Hartman, and to present topics such as this. So please, if you wish to present something, or if you have someone that you know that you think would give a great webinar, please contact us. You can email me at admin@acvpm.org, or you can go to the continuing education tab on our website. So thank you again, Dr. Hartman. Great talk. Getting a lot of thumbs up and hearts and clapping hands and everything like that. So um, appreciate everybody's attendance. And with that, I'll close today's session. Everyone have a wonderful day, evening, wherever you may be in this world. Thank you very much. Bye-bye.